Welcome, everybody. For our Thought Leader seminar today, I'm very pleased to introduce Neil Ward, the Professor of Rural and Regional Development at the School of Environmental Sciences at the University of East Anglia. Neil's work has always been connecting threads between social and environmental sciences, and in the context of the biophysics of agriculture. His current position follows a sterling career at UCL at the Universities of Newcastle and Leeds, and as Deputy Vice-Chancellor and Pro-Vice-Chancellor Academic at UVA. Neil is a co-convener of UKRI's AgriFood4NetZero Network Plus, which we will hear much more about from him in a moment. And after his talk, we'll have some time for Q&A. And I would ask you to please write your questions into the chat box during or after the talk so that I can collate them. Many thanks, and over to you, Neil.
Okay, thank you very much, and thanks very much for the invitation to talk today. As was said, I'm co-convener of UKRI's AgriFood4NetZero Network Plus, and it was launched in the summer and has been gearing up this autumn. And the talk really is based on some of the work I've been doing as part of that initiative. I'm going to just put a couple of slides up by way of introduction and context to my talk. The first one is just to introduce the Network Plus. So there are five members of the executive team. Four of us are co-conveners and the network champion coordinator. So Angelina Sanderson-Bellamy in the top left corner is at University of West of England. Sarah Bridle below her is at the University of York. Stefan Kopinski is at the University of Leeds. That's me on the bottom right. And Tim Benton, who's at Chatham House and the University of Leeds, is top right. And so we're kind of leading the coordination of the network, which is to bring together scientists and researchers in universities and research institutes with policymakers and practitioners to identify the key gaps and the research priorities to support the transition in the UK agri-food system to help the UK reach its net zero target by 2050. The second contextual slide I wanted to show is just this diagram from the recent IPCC report, and I don't want you to sort of get too absorbed in the detail of it, but the key message for this diagram is to illustrate that the 2020s are an absolutely critical decade in reducing greenhouse gas emissions and getting the transition underway in such a way that we avoid the risk of really seriously sort of catastrophic climate change. And if we're not on track by the end of the 2020s, it really does become very, very difficult, not impossible, to get onto a pathway where we have sort of higher resilient, sustainable development, which is the sort of green pathway. So the 2020s is absolutely critical decade for viable, plausible, successful action to mitigate greenhouse gas emissions. In that context, the global agri-food system is producing more emissions at the moment. So in the 3 decades since 1990, the general trend globally is for emissions to be increasing from the agri-food system. And agri-food system emissions are around 1/3 of total greenhouse gas emissions at the global level. In the UK, the emissions from our UK agri-food system have been coming down gently since the 1990s. But the problem is they're not coming down at a sufficiently steep pace. So it's not as fast as they need to be coming down to help contribute sufficiently to meet the net zero target by 2050. So that graph needs to accelerate and come down more steeply. Within the agri-food system, the agricultural sector has a chart like this for its emissions. Now, these measures are estimated, by the UK government and are part of its annual reporting to the Framework Convention on Climate Change. That countries are required to send in an inventory of all of their emissions. And so this is what the data tells us are the estimates for UK agriculture. And the key thing to say here is that emissions did come down from 1990 to around about 2007, principally as a result of reduced numbers of cattle. But since 2007, 2008, the trend has been at best flatlining, possibly even up a little bit. So there hasn't, we're not on a trajectory of declining emissions from the agricultural sector at the moment, and haven't been over the last decade or so. So what I'd like to do is spend a bit of time thinking about the UK agri-food system and the challenge that getting to a net zero UK poses. So this is for the agricultural sector, for the wider food system, and for the pattern of land use. If anyone's interested in reading more about this stuff, then a really good place to start is the Committee on Climate Change, well now called the Climate Change Committee's report from January 2020, which is featured there on the left, Land Use Policies for a Net Zero UK. So the UK made its net zero statutory commitment in June or July 2019. It was one of the last things that were done under Theresa May's premiership. And then in the following 6 months, the Climate Change Committee were working in a focused way on land use and agriculture. And this report is the first sort of objective, independent, quite holistic analysis of what the implications of the transition might be for food, farming, land use. So there's three broad areas of reduction that contribute to the pathway of reduced emissions. There are more, but they can be grouped under these headings. So there's dietary change and reduced food waste, land use changes, and changing farming practices. And so that's the way I'm going to structure the rest of my talk. And we're going to think about those from the perspective of the global level and then the UK level in particular, and then reflect a little bit on some of the dynamics of the transition and some of the dilemmas. So this pie chart on the left just shows the way that in that January 2020 report, the Climate Change Committee carved up the distribution of reduced emissions. So there's 69 million tonnes of CO2 equivalent reduction in that January 2020 report. The numbers do move around a little bit, and the CCC have produced subsequent reports with slightly different numbers, but the broad pattern remains roughly the same. And under those components that I've highlighted, dietary change contributes around about 20% of the reduction. Forestation and energy crops is around about half of the reduction. Lower emission farming practices are around about 12.5%. They are numbers that come from the 6th carbon budget, which was produced by the Climate Change Committee much later on in 2020. And that's the main volume that's providing advice to government on the patterns and trajectories of emissions reduction to keep us on budget to get to net zero by 2050. I'm just going to say a little bit about the way conceptually I approach this question. So I started thinking about net zero in early 2021. So I've been thinking about this for about 18 months, but it does sort of return me to some of the themes that I explored in the early part of my career, where I was looking at the history of British agricultural policy and the emergence of various environmental problems around landscape change, loss of biodiversity and habitats, water pollution from farm wastes and pesticides, and then animal health and welfare problems. from the 1980s onwards. And I think it's quite useful to think about the net zero challenge for the agri-food system in the context of the sort of broad historical sweep of change that we've seen over the last century and a half in the UK. So if we take a sort of 100-year run up to the present moment, or perhaps a bit longer, then the key thing is that there was a very prolonged period from the repeal of the Corn Laws in the mid-19th century right through to the 1930s, where the UK had a very distinctive and very laissez-faire approach to food and farming. So we were an imperial, we had the British Empire, we had imperial trade relations around the world, and the dominant approach to food was that we would source our food as cheaply as possible from wherever it could be grown and got to us as cheaply as possible. So there was no particular support for farmers, no subsidies. There's a little bit of intervention at the time of the First World War, but that unraveled in the 1920s. So broadly, you can say from the 1850s to 1930s, no support for farming. Farmers were just having to produce and compete on world markets, and we got our food from wherever it was cheapest. So at the time of the outbreak of the First World War, we were about 30% self-sufficient in our food. We imported about 70% of our food. And that proportion didn't really change much right up to the Second World War. In fact, it probably came down a little bit by the start of the outbreak of the Second World War, 1939. We were still only about a third or a little under a third self-sufficient. The experience of the Second World War completely turned that around, and we developed a new model, which was to maximize our production from home land resource. Very, very strong state support and intervention to manage the agricultural sector. And that model, which was forged in the Second World War, carried on into the 1950s and 1960s and right up to our entry into the common market and the common agricultural policy. So there's strong state support and direction of agriculture. There were guaranteed markets and guaranteed prices. Farmers knew exactly what they were going to get, how much money they were going to get. And there was a lot of intervention, subsidy, grants, advice, and persuasion to encourage technological modernization led by the state and a network of public research and extension agencies. And that trundled on until the 1970s and really into the 1980s as well. Although by the 1980s, there were growing concerns about overproduction and also about the environmental side effects of the model that was developed in the 1940s. So loss of valued habitats and species, water pollution problems, and a set of other issues as well. And so we see from the early 1980s the gradual development of agri-environmental schemes, voluntary schemes, to pay farmers to farm in economically suboptimal ways for the sake of environmental protection or environmental enhancement. We also saw from the 1980s onwards areas of agriculture which became much more tightly regulated. For example, some pesticides taken off the market because of their persistence in the environment, fines for water pollution, restrictions on livestock waste storage facilities, and so on. And there are also tighter regulations around animal health and animal welfare, and some on air pollution as well, like a straw burning ban. After 2015 and the Paris Agreement, which committed to keeping global temperatures to within 2 degrees and ideally within 1.5, then greenhouse gas emissions are sort of beginning to frame and impinge upon how we think about agriculture and the food system much more than hitherto. And so from 2015 onwards, it's gradually coming into sharper focus what the Paris Agreement and the need to reduce greenhouse gas emissions is going to mean for food and farming. So if we just turn to those three areas that I flagged up, the dietary change, the land use change, and the changing farming practices, we're going to look at each of those in turn, just a couple of slides on each. First slide just takes the international context. And the diagram on the left is a little bit blurred, and again, it's one where it's not really necessary to absorb all the detail of the text, but what that diagram is just trying to show is that different types of foods have different levels of emissions. That's the first point. So it's nuts at the bottom, the kind of pink one, and then peas and beans, and the green one is tofu, and it's beef and lamb at the top, the blue one, and the brown one. And the 2 points to take away are that the blobs are to the left at the bottom and move to the right, but also as they move up, they become more wide ranging. So the range of greenhouse gas emissions from beef production is quite a wide range depending on the type of production. Whereas with nuts and peas down the bottom, it's not very diverse. You know what the emissions are, and they tend to be quite low. There was a really interesting report by the Eat Lancet Commission, published in the Lancet in 2019, which was a modelling exercise to address the question: if we have 10 billion people on Earth, can we feed them all with a healthy diet and still save the planet from catastrophic climate change? Which is a good question to ask. And it's an international panel of scientists and sort of food system experts and modelers, and they produced this work, and it concluded that yes, it would be possible to feed a human population of 10 billion and keep within operating limits, but the thing that would need to change would be the diet. The healthy diets would have to have a much higher representation of low emission foodstuffs and a much lower representation of higher emitting foodstuffs. So that was quite an interesting sort of global framing exercise, and it has informed work within the UK. People haven't taken that modelling as sort of gospel truth, but it does provide a useful framing, and it opens up this question of managing dietary change to bring the food system and food consumption within global climatic environmental limits. So it's highly processed foods and ruminant meat that are the biggest sources of emissions. And what we find, taking a global perspective on this, is that as nations become more developed and average income levels grow, so associated with that is an increasing demand for meat. So as the international economy develops and countries develop, so they tend to move towards consuming more meat. So that trend in meat consumption and economic growth on the one hand, and climate change and population growth on the other, those two things are in quite sharp tension. So we see a lot of debate now about meat and a lot of interest in low emission potential alternatives to meat. So there's, you see lots of coverage of plant-based proteins and lab cultured meat and that sort of thing as potentially emerging technologies. I think this is most vivid in those meat-free sections of the supermarket aisles that you walk along that seem to be getting more and more expansive. So in the UK, taking the Climate Change Committee's work from 2020 and the way that that's developed since then, independent scientific opinion is suggesting the UK needs at least a 20% reduction in the consumption of the most highly emitting foods by 2030 and a further 15% by 2050. So that's from the 6th carbon budget. Those figures are a bit higher than in the January 2020 report from the Climate Change Committee, and probably one of the main criticisms of the January 2020 Climate Change Committee report was that its prescriptions on dietary change and reduced consumption of the most highly emitting foods were a bit on the modest side. The National Food Strategy that was led by Henry Dimbleby and published last year, that talked about a 30% reduction. So we're seeing figures in the range of sort of 20%, 30%, 40%, 45% by 2050. So quite significant reductions in consumption of high-emitting foodstuffs. Interestingly, when the government produced its net zero strategy about just over a year ago, in the run-up to the Glasgow COP, the strategy didn't talk much about agriculture and food. It did talk about tree planting, which I'll go on to in the next section, but it didn't mention food much. And there was an interesting report produced by the Behavioural Change Unit, Behavioural Insights team, I think they're called, that was published alongside the net zero strategy and its accompanying documents, but it was quickly withdrawn. It was an accidental publication, and it looked at what works in encouraging behaviour change amongst consumers for the sake of climate change. And it was a very interesting report because it really strongly focused on the need for system level change, that you can't just focus on individual behaviour of isolated individual consumers in the supermarket or in the marketplace making their consumption decisions. It has to be the environment, the supply chains, the whole system. So that was what that report said, but it was published and then quickly withdrawn. So quite revealing and interesting to look at. I think essentially what's happening here is there's quite a fear about accusations of nanny statism and government preaching or acting to manage how people eat and what people eat. So that's a very politically sensitive issue, sensitive for both main political parties, but probably a bit more so on the right than the left. So we're going to move on to land use and land use change and the global context for this. So the IPCC produce their assessments every few years, and over recent years they started to develop more thematic work, and in 2019 they produced a report that was dedicated to the question of climate change and land. So it's a global analysis produced in 2019. At the Glasgow COP, there was a set of deforestation commitments that were made about bringing to a halt net deforestation. Globally, there's a lot of interest in energy crops and bioenergy, carbon capture and storage. This is where you grow energy crops and burn them for energy, but capture the carbon through an additional process and render it into a form that is sort of storable. And in the UK, the plan would be to then pump it back into the North Sea oil and gas wells and keep it there for good. So the growing of the energy crops is drawing carbon dioxide out of the atmosphere and is then rendered into a storable form. That technology is still under development. There is one working centre in the US. There's a plan for 4 or 5 clusters in the UK, but there are none up and running at the moment, and a lot of sort of debate about the technical and economic feasibility of that. But it does feature as a key part of the emissions reduction plans for lots of countries. So at the moment, it's very much part of the mix of how we're going to avoid catastrophic climate change and reduce greenhouse gas emissions. The key thing is that energy crops to fuel bioenergy, carbon capture and storage would use land and would compete for agricultural land with food crops. So there's an issue here of needing to produce the same amount of food or more food from potentially less agricultural land, because some land will be needed to grow energy crops on. And of course, also climate change itself will affect agricultural productivity across many parts of the world. So we've got a set of pressures on land and the place of agriculture in land use that are quite marked and are going to lead to a lot of scientific research, but also a lot of land use change over the next 2 or 3 decades. In the UK context, so the chart on the left is from the National Food Strategy and rather nicely shows how UK land is divvied up between different land uses. So you've got cereals and beef and lamb pastures, you can see there. And you've got the woodland at the top, broadleaf and conifers in the Scottish Highlands. We're going to have to plant many, many more trees our forest cover is going to have to expand from about 13% of our land area to possibly 20% of our land area. So we have 3.2 million hectares of forest at the moment, and that needs to get up to possibly 4.5 million hectares. We're planting around about between 10 and 13,000 hectares a year at the moment, and that's going to have to get up to 30,000 by 2025. So it's going to have to treble very quickly, and potentially up to 50,000 a year by the middle of the next decade. So there is going to be a real gear change in planting trees, and it's going to have a significant effect on the UK land use and landscape. Energy crops and BECCS, bioenergy, carbon capture and storage are in the mix, and the hope is that they will be on stream from the 2030s and delivering a share of mitigation. We're going to have to restore peatlands in the uplands and some in the lowlands as well. The lowland peatlands are, of course, a highly productive agricultural land. The critical thing from a UK perspective is the Climate Change Committee is assuming that by 2050 we'll be operating with of the order of a quarter less agricultural land than we have today. So the government has said it wants to maintain production level. It doesn't want us to become more dependent on food from elsewhere. So we will be needing to produce the same amount of food, but from about a quarter less land in 28 years' time. So the third strand is farming practices. And globally, the World Resources Institute produced quite an interesting study a few years ago about how to carve up the challenge of raising agricultural productivity to feed the world and within environmental constraints. So this leads to a set of strategies around improving the productivity of livestock and pasture through animal breeding. There's quite a wide range in the productivity of agricultural animals. So if the lower productivity systems could be brought closer to the average or higher levels, that might be one area of potential improvement. There's improvement that can be done through crop breeding to boost yields. There's all sorts of changes that can be done to soil and water management to help maintain and improve agricultural productivity. There are parts of the world where cropland could be planted more frequently. And a key part of the challenge is allowing or supporting agricultural systems to adapt to the effects of climate change, which is inevitable and is already affecting productivity of agriculture in lots of parts of the world. Globally, this is leading to a sort of debate between two rather contrasting or seemingly contrasting sort of ideological starting points, really, or scientific starting points as well. The first of these is land sparing. So I've explained we're likely to need to find spare land to do afforestation and energy crops, yet still produce the same amount of food. So that has led to a logic of sustainable intensification. So the application of more knowledge and technology to existing farmland to increase its productivity. So it's quite an agri-centric and technologically driven approach, and tends to be called sustainable intensification. And that means that the food can be produced on less land, which frees up spare land to use for other things. A contrasting starting point comes from a more ecocentric or ecological point of view, and this is typically termed land sharing, and that's where the nature conservation and the greenhouse gas emissions and the biodiversity management happens alongside and intermingled with the agricultural production. So this is a concept of regenerative agriculture or agroecology or agroforestry and trees on farmland. So that's a sort of alternative. In fact, there's large areas of overlap between the two approaches. but we're seeing that sort of emerge as an interesting and quite constructive sort of debate and tension between different pathways and different future worlds. In the UK, I'm not going to go into a lot of detail on this, but I can point you to more detailed material. It's really ruminants, so that's cattle and sheep in particular, that are a really significant contributor to our emissions. So these are the animals with several stomachs that sort of the food gets regurgitated backwards and forwards, and they are emitting from their bodies enteric emissions, enteric fermentation. But at the same time, and perhaps less discussed and less popularly understood, is that there are emissions from greenhouse gases, particularly methane, from the handling and storage of the manure and the slurry from cattle in particular. So that's probably the biggest, enteric fermentation and manure and slurry management. There are emissions that come from the use of manufactured fertilizers and from the application of manure and slurry as fertilizers as well. There's the use of fossil fuels by farm machinery and in the heating of farming buildings. And so in the UK, we see this land sparing and land sharing debate and tension in play as well. And there's a sense in which it reflects earlier discussions about multifunctional agriculture and about nature conservation and the loss of farmland, birds and things like that, where it's probably 10, 15 years that this idea of land sparing and land sharing has been in play as a debate and precedes the rather specific issues of reducing greenhouse gas emissions to meet net zero. So there's an interesting set of dilemmas around the policy measures and the practices that might get UK farming practices and UK agriculture onto a path that is going to sufficiently contribute to greenhouse gas emission reduction. And that is around whether this is a question of technologies and technical fixes, or whether there is a need to change hearts and minds and reimagine the whole notion of what it is to be a effective and responsible farmer and land manager. So I'm going to start to draw to a close so that we have time for questions and discussion. Just a few slides towards the end then about the dynamics of the transition, and I'll return to the UKRI AgriFood4NetZero Network as well. The first thing to say is we will be needing a system transformation, and it's not going to just occur on its own. So this is going to have to be a transition that is managed and planned and thought through and quite strategic. And so that does jar a little with rhetorics and ideologies about free markets and people being free to do what they like and choose to do what they like. The state did play a very important role in the last major technological transformation of agriculture, and it was quite a profound transformation, just in terms of the types of technologies used, the impact on the landscape, but also, most significantly, the impact on productivity in the major agricultural commodities. Since the 1980s, environmental concerns have been brought to bear on British agriculture and the food system, but they haven't generally led to fundamental system transformation. They've been add-ons. Environmental concerns have been taken on board, certainly, but without necessarily changing course. And that's a phrase that we coined in a book which was focused on the problem of farm waste pollution, which emerged in the 1980s, and the regulatory response to it was really in the early 1990s. So acknowledged as a problem, accepted that there need to be measures to deal with it, but they were sort of accommodated taken on board within the existing production systems, and system level change and transformation was something that was generally avoided. What's clear from the scale of the challenge and the emissions reductions that are going to be required from the agri-food system is that greenhouse gas emissions and the budgeting of our trajectory to net zero is going to really have to frame policy approaches to agri-food and land use in a way that it isn't quite yet. So I thought I'd try and do a sort of balance of what are the grounds for optimism and what are the grounds for pessimism in facing this quite complex technological but also social and economic challenge. So in terms of optimism, we have been through past technological transformations of a similar order of magnitude to the one that's required. I think it's quite useful that in dietary change, climate drivers are aligned with public health drivers. So we have a public health problem, an obesity problem. There's increasing need being placed on the National Health Service because of poor health associated with food consumption patterns. And in fact, the public health, if we were to all have a healthy diet in nutritional terms, the emissions problem would be solved. So health and climate are absolutely in lockstep with each other. And if we solved the greenhouse gas emissions, that probably wouldn't have gone far enough to solving what it is to be a healthy population with far fewer of the problems associated with consumption of unhealthy foods. Also grounds for optimism in terms of the science and social science of behaviour change, where the growing number of specialists who study behavioural sciences and think about behaviour change for climate change are recognising that it's the environment, it's the system, and it's system level change that's required. So we're seeing a move away from the emphasis on just trying to nudge and persuade the individual consumer to thinking about the context and the system. And we do have some examples of regulatory forcing measures which have worked, like the sugar levy, for example, which was introduced a few years back and has been quite marked in its impacts in reducing the consumption of unhealthy, sugary, fizzy drinks by taking the sugar out and putting substitute ingredients in. And we also have the legislation which is prohibiting the sale of new petrol and diesel cars from 2030. So only 7 and a bit years away, which is already stimulating system change in surface transport. On the other side of the equation, pessimism. Well, the experience in the UK from 1980 to 2020, the last 40 years of greening farming has been quite a mixed bag, with quite a lot of money being spent, patchy results, and we still have problems with water pollution, for example, of agriculture being quite a significant contributor to water quality problems in rivers in the UK. This pathological political fear of nanny statism around food and food consumption is a challenge, and it's something that there's going to have to be a bit of a national conversation about at some point if we're to successfully get on a appropriate pathway by the end of 2020s. The issue around meat is leading to quite a heated and polarized argument between sort of just business as usual versus veganism, but that isn't really what the debate needs to be about. It's about how do we get onto a trajectory where less higher emitting foods are consumed, and that does mean less meat, but it needn't necessarily mean no meat. And the other area for potential pessimism is that the BECCS technology is still unproven and is still quite a large part of the equation. So to draw some final conclusions, the 2020s to 2040s system transformation, I think, is probably less materially significant and challenging than the changes that we went through from the 1940s to the 1960s. But it does require a more profound mindset change. It goes against the grain more probably of prevailing ideologies in the food system, and it's likely to require much stronger vision and leadership than the changes in the post-war period, which I think is not there yet. Agriculture and agri-food currently lags other sectors. The Climate Change Committee is very polite, but it does, with each report, criticise DEFRA in particular and the agricultural departments in general for the lack of clear plans and strategy on emissions reduction and lack of targets. So at the moment, as other sectors progress in their emissions reduction, like electricity generation and surface transport, so agri-food is going to loom larger as a thorny challenge, and it's one where at the moment change has been a little bit incremental. There are important lessons from the last 40 years experience of trying to green agriculture, and the biggest obstacle is probably the neoliberal timidity about actively managing markets for the wider public and environmental good. So I was just going to conclude with just a couple of slides to give a little bit more detail on the work of the AgriFood4NetZero Network. There's a wide range of organisations that are involved. You can see UEA is there in the John Innes Centre, and we had 11 co-Is on the grant and several other partner organisations as well. So we've got good coverage across Scotland, Northern Ireland and Wales. We conceptualised the scientific map, if you like, of the challenges in three sort of vertical columns: sustainable production systems, that's crops and livestock, land use for sequestration of CO2 is the middle one, and the final one is around supply chains and consumption. And in each of those spheres, we're taking a sort of horizontal take on it around novel technologies and analytics, around systems interaction and complexity, because these things are all interconnected, and around questions of individual and institutional behaviour change. And so given that map, we've appointed 9 champions, and I think this has just been announced on Twitter today. So we've got these 9 champions from different institutions who are leading brainstorming and coordinating work to identify research gaps, areas of potential to progress, and building stakeholder communities around their themes. And they're working, they're not isolated cells, but they're kind of intersection points, and they're working individually and in groups and clusters to sort of animate activity and to engage with scientists and stakeholders around those questions. So I'm going to draw to a close. That's the sort of 35-40-minute version of my thoughts on net zero food and farming and the UK agri-food system. This is the 100,000-word version that you can read at your leisure, available from all good bookshops. And if you're interested in finding out more about the Network Plus, then you can look at the web page there and you can sign up and join, and you can get updates on activities. There's going to be a lot of activities, particularly after Christmas, kicking off. It's going to run for 3 years, and you can follow us on Twitter, and you can follow me on Twitter if you like as well. So I'll pause there. Thank you very much, and over to the chair.
Thank you, Neil. That was a fantastic talk and very stimulating. We've got some great questions on the chat, and let's start off with one from Rob Grant regarding what you showed on the UK agri-food and agriculture emissions, especially from cattle coming down. Is that driven by reduced numbers of cattle or by changes in grazing practices? And also, does that include imports?
What was the last word?
Does that include imports?
Imports. Right. No, it doesn't include imports. That's just the UK. So it is an interesting feature of the international framework for governing emissions reduction that we are responsible for the emissions that come from that are produced in our economy, and not from the imports. So that's the imports are coming from somewhere else, so they get counted on someone else's books. So we have to be careful that we don't manage our transition in a way that just sucks in more imports from other places. Although the critical thing about imports coming in from other places is not the fact that they're coming from another place, but is what are the emissions associated with their production and transport. So if something's coming from the Netherlands, it's not inherently bad because it's coming from the Netherlands. It's the question is, are more emissions involved or not? And if the emissions are lower from elsewhere, then it might be fine to have food coming from elsewhere. So we have to judge these things on the basis of emissions. And that's going to be a new way of thinking, because actually, as an island nation, we're kind of fixated on bounded questions of food security and self-sufficiency. So that's the bit on imports, which was the last word, and all the other words were about livestock, weren't they? It's principally about reduced livestock numbers. There are changing practices underway, and there is an elaborate model which sort of assesses and measures to estimate emissions from the livestock industry. But the main driver of that reduction was reduced numbers.
Question from Natasha Grist. The UK net zero strategy from last year largely ignored dietary change and the Climate Change Commission clear recommendation on that. So was that on purpose due to perceived UK people's backlash or lack of popularity of this?
So I think it's about a political anxiety. I'll try and use neutral terms. There's an anxiety amongst the political class around developing prescriptions around healthy food at the moment. And it is something that, we've had a government of one particular colour for the last 12 years, but you can find material in that shows that Tony Blair, for example, was quite cautious and rather nauseous about some charges of nanny statism as well. But other countries, I think, are less inhibited about thinking about this, and there are examples in history of all sorts of cases. Finland's quite an interesting example where there have been quite active national programs to change diet or change alcohol consumption, stuff like that have met with some success. So I think it's something we're going to have to talk about more. But at the moment, politicians generally don't like to talk about it. But the scientists and the specialist experts, I think, are increasingly clear that it's unavoidable, and it is a large sort of emitting elephant in the room.
Very interesting. As a follow-up to this, and this incorporates some of the comments that Tim Lang made, given how controversial and potentially toxic this discussion has become politically, what tools do you think policymakers can use in practice to push diet change?
What tools? So this is being thought about by the behavioural change specialists. And there's interesting research on whether people are motivated by sort of their personal well-being or by a sense of social conscience, and whether that social conscience plays differently if it's an environmental issue compared to a social issue. I think that there's a real fondness around the National Health Service in the UK, and it might be something to think about in terms of when you look at a population level as an aggregate level, and you look in terms of decades. This is going to be something that's going to impinge on levels of taxation and the fiscal health of the nation in 5, 10, 15, 20 years time. Our diet is an economic issue, it's a health issue, it's an NHS funding issue. I think it's just about finding the framing and finding the language to recast it in those terms. But it's not easy, I'm sure.
Thank you. Now a question from Jez Fredenberg. What about waste? We waste about 1/3 of all the food in the UK. Should we be focusing more on this? And is this an opportunity for government policy?
Yes, and that's something that I didn't talk about much in the talk. I talk about it a little bit more in the book, but probably not as much as it warrants, because there are some interesting organisations like RAP who do a lot of work on waste, and certainly waste is like a there's not an anxiety about that particular issue in the same way as there is about diet. So it looks intuitively like something that's going to be people can kind of get behind without feeling that it's the sort of nanny state. It won't go all the way, but it is something that's probably less politically contentious, could enjoy wider public support. It does require quite a change to sort of everyday life and everyday social practices. I mean, there's waste all along the chain. There's a lot of waste in agriculture and crops left in the ground and things like that. And then there's waste in processing, and then there's waste in retail. We've got the evolution of a really quite sophisticated and elaborate sort of social support network around food poverty, which is taking waste food from supermarkets and getting it through food banks to people in need. So there's an awful lot of activity there to address food poverty and the social needs around food, which is addressing some of the waste problem. But for more affluent people, it requires a whole different way of sort of planning your everyday life and shopping and eating. So in that sense, handling food waste in the household gets quite close to dietary change. So yes, there are some wins in waste, but it won't be enough on its own.
Okay. Now a question from Anne-Marie Minahan. Is there any meaningful move towards greenhouse gas emissions being included in the production of national dietary guidelines, which are normally just based on health measures?
Yeah, so that's really interesting. I'm not an expert in that sort of area, but in our team we have Sarah Bridle, who is a physicist by background, but got very interested in emissions accounting of different foodstuffs, and has produced a really nice book called I think it's called Food and Climate Without the Hot Air, which is a sort of user's guide, very scientifically sort of rigorous on emissions from different foodstuffs. So the science there is developing quite nicely. There are all sorts of conundrums about how you sort of distill what are quite complex calculations around emissions into a single sort of measure, but I don't think that's beyond our wits. And actually, if you sit at a table and look at the back of a cornflake packet or a jar of Branston pickle or something, and look at all of that complex information that's there, I mean, I find it personally really difficult to interpret, but that's all about ingredients, which is sort of driven by, which is sort of about people's health interests. So if we can do that, maybe we should be getting to something that's quite pithy and easy to understand. A single metric, ideally, I think would help so that people can understand it.
Great. Now a question from Mark Pallen. Is avian flu going to render egg and poultry production uneconomic, and will this have an effect on emissions?
Oh, that's a good question. I don't know that I can answer that authoritatively. I can waffle on, so avian flu is quite a big deal. It's really causing quite acute problems, particularly in this part of the world. I think there's a worry about it potentially, becoming a pandemic and affecting humans. Don't want to worry everyone, but it could be the next COVID. So it's something that we should be paying attention to and keeping a watching eye on. I've heard accounts on the BBC on Farming Today and things like that of people's businesses being, completely wiped out by it. So it's really grim and economically quite catastrophic for some individual producers. But I don't know what it's going to mean for emissions. It's something I'll need to look up.
Okay, thank you. This is perhaps more a clarification question from David Barling. Does the budgeting of greenhouse gas emissions of agriculture include carbon stocks and sinks on farmland soil in the UK?
Right, so that's another good question, and I'm getting to grips with the detailed accounting. So the Climate Change Committee in its report was looking at sinks. So it was looking at, and in terms of the sixth carbon budget. So the framework is provided globally, and so we have to use that particular framework. So we have agriculture, and then we have land use and land use change. So the carbon sequestration does feature in those calculations, I think. But the reports come out annually. It's usually a report of about 500 or 600 pages with about 400 or 500 pages of appendices and annexes. But you can access them all from the United Nations, and you can. That's where you find out the answer to David's question. Yeah.
Okay, thank you. Now, a question that incorporates some of comments from Jess Friedenberg. There's been a lot of talk about and controversy around the potential of regenerative grazing for carbon sequestration and biodiversity. What role do you see for that in UK agriculture?
Yeah, and that's one of the issues that helps break away from this sort of quite polarized argument that the problem is all about meat. We have to reduce livestock numbers. Let's get on with it. And the sort of more nuanced issue in the middle of that polarized debate is different grazing systems lead to different levels of emission, and some potentially are net beneficial even. I think the science on the different levels of emission from different grazing systems is proceeding apace, but there's still a lot to be done on that. And that's why we've got a bit of a challenge, because at a global level, the situation looks quite clear. When you come then down to individual nations, you've got a much more nuanced picture. When you come to individual farms or farming systems, it becomes even more sort of sophisticated and nuanced. And of course, complexity is a bit of an enemy of the, we've got to get viable strategies by the 2020s. Otherwise, we're in a real muddle. So whilst I certainly think there's legitimate sort of grounds for more research into low emission livestock systems, I don't think that that's necessarily a panacea, and I think it's unavoidable that we will have to have fewer livestock, not necessarily just from the point of view of reducing the emissions from the livestock, but because we need that land. And that's not the land that the cattle are necessarily grazing on the pasture systems, but it's the very large proportion of our cereal production, which is going to grow animal feeds to feed to farm animals. So that's a really big part of the equation. It's the need for that land for other purposes, to grow other food stuff for humans and other uses like growing trees, that we need fewer livestock, not just for the emissions that come out of the livestock themselves.
Thank you. Now a question just popped up from Oliver Springate-Babinski. Isn't the risk of averaging out across emissions across an entire food type that we continue to squeeze expansion of corporate farms and squeeze out small farms?
Is the risk of averaging out across the food stuff that we lead to? Well, I'm going to sort of separate those 2 points, really. So there has been structural change in agriculture for decades and decades and decades. And the framework that supported production and the uptake of mechanical and chemical technologies in the 40s, 50s, 60s feel massive structural change. And the development of silage and concrete-based, slurry-based systems for housing livestock on dairy farms and intensive beef farms has led to an awful lot of structural change. So an average dairy herd in 1960 was 20 cows, and in 1990 it was 60 cows. This is in the UK. And now, I don't know what an average herd size is, but it must be upwards of 150 cows, 200 cows maybe, I don't know. And there's far fewer dairy farmers. So our milk is being produced by a radically shrinking number of dairy farms, and that trend, has been underway for decades and decades and decades. So I wouldn't at all be surprised if the net zero transition and its implications for land use and farming practices has some impact on structural change. But it's not that there's no structural change and it would force some. It's that it would have an influence on the trajectory of changing agricultural structures, which is sort of already underway and in play. And it could potentially be that sort of multifunctional land use with some forestry and food production and other sort of mitigation measures, could potentially lead to more of an agricultural structure that Oliver might like more. I don't know. So these things are a bit morally charged, but there has been lots of structural change already. And whether you think that's a good or bad thing, I think inevitably mitigation will have some influence on that. I'm not too sure, really. I think probably the bigger structural issue is all the afforestation. So in mid Wales, there's quite a lot of anxiety about big forestry companies buying up whole farms and planting trees all over the land, and what that means for agricultural communities in remote rural areas of Wales. So probably the forest will be a bigger driver than the diet change.
Okay, thank you. We'll have one more question. Apologies to everyone whose questions didn't get asked. I'm trying to prioritize the people who haven't had a question asked yet. So final question from Zoe Rickards, which is, what about vertical farming? Do you see this as a potential solution to land use issues?
It's potentially got a role to play. It's sort of very interesting. Agriculture is full of, agri-food system is full of these sort of silver bullet golden scenarios that just come over the hill every now and again, and that's just the latest one. And there's lab-based food as well. Lots of people are talking about, and yeah. I'm sure it could potentially have a role to play in sort of salad crops and horticulture and possibly other things as well. And you have some nice solar panels on the roof, and it might help with emissions reduction in all sorts of other ways. So yeah, I think that's an interesting phenomena. I'm sort of cautious about leaping onto any of those things and hailing them as the silver bullet, because I don't think it usually works that way.
Great. Thank you very much for a fantastic talk and for a really interesting question and answer session. The recording of this, I hope, will be available soon on the NIST website. And thank you all for coming to this Thought Leader seminar. Please have an eye on our website for other seminars coming up. Thank you very much.
Okay, thank you.